All right, good day, everyone. So today we're going to be looking at a very basic hydrostatics problem. And you can find this on page 6 in your textbook, example number 3. And what it says to us is we have a box-shaped barge that floats in seawater with a relative density of 1,025. Okay, so here's the relative density of the seawater, and you can see that it's unitless, all right? Because when we're working with relative density, we're comparing the density of the substance over the density of fresh water. So it's unitless. And they say to us that this box-shaped barge is displacing 30 cubic meters of the seawater. And remember now, so if this thing is floating, there has to be a force that's keeping it up, right? And here you can see there's an upthrust from the water. Now, when you push this barge or anything into the water, what happens is the water gets displaced. It pushes the water away, right? When you take that object out again, what happens? There's a void there, and that water just pushes itself back into that void, all right? So as this barge is in the water is constantly pushing against it, right? So we can draw some arrows here, from the seawater pushing against this barge, right? And we also know that because the pressure over here is greater than the pressure up here, because the deeper you go in the water, the more that the pressure increases, okay? So because of this pressure difference, if we take this force now and we combine it into one force, it creates an upward thrust, okay? That's pushing against this barge. That's trying to push it up, all right? Keep it up. So now what they want from us is they want us to determine what is the weight of this barge. Okay, so very simple calculation. So we looked at Friday and we looked at this. Relative density equals the density now of the seawater over the density of fresh water. And we know what the density of fresh water is, 1,000 kilograms per cubic meter. And we've been given the relative density of this particular seawater. And then we can calculate what the density of the seawater is. And that comes out to be 1,025 kilograms per cubic meter. All right. Then we can calculate what the mass of that volume of seawater that was displaced. So we have the density of that seawater now. We have the volume, which is 30 cubic meters. And then we can calculate what the mass of that seawater, that 30 cubic meters of seawater that was displaced, the mass of that is 30,750 kilograms. So the weight of the seawater displaced, if the mass is 30,750 kilograms, the weight of the seawater then is 30,750 kilograms of force. So we're not dealing with newtons yet, so we're just going to say that this is 30,750 kilograms of force. All right, so for this barge to be floating, the upthrust now, according to Archimedes, must equal the same as the amount of water that is displaced. So the upthrust over here is also 30,750 kilograms of force to keep this barge up. All right. So if that is the case, if the barge is floating, like I said, the upthrust must be exactly the same as the weight of the barge. So therefore, the weight of the barge is the same as the upthrust. All right, so the weight of the barge is 30,750 kilograms of force.